Well, hey there! Here we go into lesson 3 where we're going to go over a very BC specific topic known as vector valued functions. In the BC exam, oftentimes you're going to be given vectors, but it's not vectors like the formal study of it like you may have studied in physics, like you will study in calculus 3, multiple variable calculus or multivariate calculus. This is just the very basics of vectors. So we're going to dive into that right now and go over the fundamentals in this video before going over the calculus of them. So what is a vector? Well, a vector is essentially a directed line segment that represents any quantity that has any kind of magnitude and direction. So the wind, force holding you down on the earth, speed with direction. So anything that has direction and an amount. That's what a vector is. And it's generally represented with a ray from geometry or just an arrow pointing in the direction in which something's going, and the length matters. So the shorter a vector is, the less magnitude or the less amount of whatever it is that we're measuring that vector is. So like if this was measuring the velocity of the wind, they're both going in roughly the same direction, pointing in the same direction, but this speed of the wind is much greater than that speed is, just as an idea. That's it. Okay, on to the next bit. So we first learned about derivatives, and then we explored their applications in the real world. So you learned about them as like motion along a line. You did position, velocity, and acceleration. And now we're going to do that, but we're basically going to apply that into space, into 2 dimensions. And we're going to use parametric equations as the mathematics behind it. So it's basically time for us to see how our knowledge of the calculus of parametric equations can be used to describe motion along a curve. Again, in 2 dimensions. And this might sound like repetition, might look like repetition. Visually, to do all this, we use vectors, those arrows that we talked about. So just a general overview, and then we'll get deeper into this. Again, this video is a very brief overview of vector valued functions. So velocity and acceleration vectors and speed come into play as well. Eventually we'll get into speed, eventually. That'll be probably in the second video. So a position vector describes the direction and distance a point or object is from where it started. Think of it like a baseball or a basketball is shot from a starting point. And then an arrow represents from its starting point to where it currently is. We don't generally graph out the position vectors, but that would be like if you shot a basketball from here to here and froze the frame, the position vector would be like you looking at the basketball from here all the way to there, and it's generally plotted as a point. A velocity vector describes the direction in and speed in which or with which a point or object is traveling. So that would be like if we take a look at the arc of this basketball and we look here and we're like, oh, whoosh, that basketball is going up at, 10 miles an hour and to the right at 7 miles an hour. So this overall would be the velocity vector. It's made up of 2 pieces. We'll talk more about that in a little bit. It's made up of y prime, how we're changing up and down, and x prime, how we're changing left and right. All right, sounds parametric? It's because it is. Again, more on that in a later video. We've got an acceleration vector. That describes the direction in and rate at which a point or object's velocity is changing. So that would say, how fast is this velocity vector changing? This is different than the second derivative with respect to x that we've seen before in parametric equations. Again, we'll go over more of that in the not too distant future. For now, a brief overview. We'll get back to this in a little while. So what I'd now like to end the video with, a very short video, as I said, is how to graph a vector valued function. This is not something you'll be asked to do in the BC exam. It might be something you're asked to do in calculus class, but probably not. So essentially, to graph a vector valued function, it's a function that's technically traced out by vectors, but really it acts like a parametric curve. So here's the notation. It's kind of weird, right? You see these 2 kind of, less than and greater than looking signs, but they're 2 kinds of brackets or grouping symbols. And essentially this means that x of t is equal to t squared. So all the x coordinates of our vector is t squared, y of t is t. So these values, these things right here, represent the x and y coordinates of vectors, position vectors. These signs right here, those symbols, indicate that it is a vector valued function, in case you see those. They're not used frequently in the BC exam, but some teachers use a lot of them. So how do we graph it? Like we've always graphed parametric equations. All right, so I'm going to do out my chart. I've got t, and I'm going to do x of t, and then we're going to do y of t. We're just going to plug in for t. Let's go like, -3, -2, -1, 0, 1, 2, and 3. Here we go. So plugging in -3 squared is 9. Plugging in -2 squared is 4, -1 squared is 1. Just doing all the x values together. Why not? 0 squared is 0. 1 squared is 1. 2 squared, thought I'd have to count a little bit. 3 squared is 9, sorry. -3 just gets plugged in for t. It's literally whatever the t value is, the y value is as well. Nice. All right, these are our points. 9, -3 gets plotted. That's down here. Let's plot that in a colorful color. 9, -3. Colorful color, whatever that means. 4, -2 over 4 down 2. 1, -1. 0, 0. 1, 1. There it is. 4, 2. That's over 4 and up 2. And then 9, 3. That's right 9 and up 3. And so that looks something like this. And yes, it's got orientation, just like a parametric curve does. Technically, what has happened here is you basically have vectors that have like delivered, right, the points. Do we plot those vectors? Oh, heck no. Absolutely not. So let me get rid of those. So you're not actually going to have vectors on there, but that's the idea. But essentially, this all just acts like parametric equations. So I don't want you to freak out and be like, wait a second, isn't this just parametric? Yeah, essentially that's what this is, but the points are delivered by position vectors. All right, so in the next video, what we're going to end up doing is actually reviewing motion along a line, something that you're quite adept with, I hope. And then after that, we'll talk about velocity vectors, acceleration vectors, and speed, and how, oh, and distance too, and how it's actually not that hard to find. It's basically parametric, y'all. I'll see you in the next video. Peace.